Hey guys, this is going to be a quick update from Wispaplooza. It starts with the Millennium guys talking about OTDRs. Obviously, if you're listening to the audio only, you can't see it, but there's a lot of good information. They're taking questions from the crowd, just really good stuff in there. Following that is going to be Brink Networks talking about some Jirous dish stuff, which I found interesting. Alright, thanks guys. Bye.
It's similar to shining a light in a mirror. You're standing right next to it. It's like, holy crap, you stand back and it's not as big a deal. That's essentially what you're doing there. It blasts right through all the events.
Yep. So then this one has the fiber wound up in there already, so no patch cord necessary. The first connector it's going to see is actually the connector on top of the machine, and then right into this one.
Is this thing able to tell you where there's a break or a bend or
That's
some sort of loss
exactly
in
what
line,
this is.
Like however many meters down the.
Yep. That's exactly what this machine does. This is for troubleshooting.
If you have a 100 meter patch cord, in that you kind of have to take that into consideration.
If you were using a launch cord, yeah, absolutely. And there's actually the first thing on that first screen right there. It asks you if you're using a launch cable, and you can click it, and it'll even measure the launch cable for you. If you unplug it from here and just hit measure, it'll tell you exactly how that is, and then it will remove that from the link.
So it already kind of takes all that into account.
Yep, yeah, it automatically takes that into consideration. So it's almost done. Yep. All right. So it's going to give you a pass-fail up at the top here. So again, no interpretation. It's either red or it's green, right? So this one failed because we've got a bunch of stuff going on in here. So let's move all the way through the link here. Again, the distance at the top says 0, 0 feet. That is this first connector here. Moving on right through, there's two connectors.
So this connector here.
Yeah.
And then the next one should be 33 plus or minus a meter.
Plus or minus a meter. It's in feet, so that's going to be some interpretation. But anyways, right on down the line here, every one of these is interactive. It's green if it's within parameters. So and you can set your own parameters if you guys want to, whatever. But usually it's 0.5 dB loss per connector and 0.1 dB, 0.2 dB for a splice. So, but you can set to whatever you want. If you want your people to do better splices, set your parameters to whatever you want. It's all totally customizable. So again, it's green because it's in parameters. The next splice is pretty bad. So this splice lost 0.59 dB at 1310 and 0.5 at 1550. So you know what? At 13,118 feet, we got a splice. So now you go back and look at your plans. Yep, you know what? That's a splice case at 1st Street and 3rd Street. So that's go back there and look at that. Now, 0.5 dB splice is not ridiculous. So you know maybe it still works. Maybe your link is still up and running. But you know if you're running into issues. So then right at the bottom here, it's going to tell you what that icon means and then ways to fix that. So this one says the connector or bulkhead is damaged, dirty, not well connected. Inspect and clean as needed. So I mean, it even gives you ideas on how to fix things here. So then all the way through. So we've got a macro bend. Inspect the fiber in this area or search for excessive bending or cable compression. So again, at 27,745 feet, got to bend somewhere. You know what? That's a patch panel. It looks like when they shut the door, they caught the fiber in the door. So it helps you identify where that stuff is. But you still have to have an idea of what your network looks like. You still have to have a map where you can go back and say, all right, here's my splices, here's where that stuff is, and then trace the feet out.
Do you use the OTDR to set baselines, meaning documents all that?
So through your link, like the first thing you want to do when you're turning up a customer, the first thing you want to do is get a power level, right? So the day that you're installing that customer, put a power meter on, you know, at the central office, and then put one on at the customer end, and then have you know technicians communicate with each other. All right, I'm seeing 39 dBm, at the customer face. Then do bidirectional. So then flip it. Some of the cheaper power meters is literally just just receiving light, and then you got to use a different machine to actually shoot the laser back out. So your technician has to have two of them out in the field. So whether you're on the phone or whether you have a talk set or whatever, do bidirectional. So power this way and then power back this way, and then you average the two. And then, yeah, you absolutely document that, because then in 6 months, if something happens, I was at 39 dBm, now I'm only at 25. What happened here? Something,
So you're basically just documenting the overall signal. You don't document distance splice loss.
Oh yeah, you want to document the distance as well, because now it was 30,000 feet, now it's 26,000 feet. What happened? Where's my brake? Yeah, absolutely. So power, your overall power, and the yeah. So that's
And they have a reporting system that comes with this that you can export.
Yeah, you can
So whether
save.
it's your splicers providing them to you guys, or you providing them to an end user somewhere else, you can provide those reports.
Everything saves on here. Everything is able to be exported and viewed by other people. There's viewer software out there, so even if you're out doing work for somebody else, they can view your traces, and it's super easy to read. It's very user friendly. So
Will the power be different in the reverse direction?
it could be. Yep.
What
So
would
if,
account for that?
couple things. If you have high reflectance off some connectors, you could have more reflectance one way than the other. Sometimes if you have different kinds of fiber out there, so maybe you have some fiber from the early 90s or something like that, and then you have brand new fiber. There is a small core mismatch sometimes. It's not going to be anything ridiculous unless you're really doing some high traffic, but I liken it to a garden hose to a fire hose kind of thing. You don't lose any water going into the fire hose, but coming the other way, you're going to lose a little bit. So that's why you just take bidirectional and then average the two. So do we have a correct tip for this? Okay. So you have dirty or damaged bulkheads in the field, right? This is for cleaning connectors. Can't tell you how many times this is your problem. If something happens in the field, my link's down. What happened? Somebody unplugged the connector and it's dirty, and now all the light that's coming through here is just reflecting back and messing up your optics on the other side. So these things are halfway inexpensive. I mean, for like $1,700-$1,800, this is going to save you so much time in the field. It's got a little screen on here. It's got you can save these, you can export it. So if you're doing work for somebody else, here's what it looked like when I left. It was clean. It was turned up. So
I believe this unit they're not all that way, but this unit is Wi-Fi enabled, so you can take a picture from the side, and if you're on the network, you can send it to a computer to save the reading.
this is a scope. Yep. All right. So kind of difficult to see. I know it's small here, but this is what the end face of the fiber looks like. Okay. So the idea is to have everything clean, right? You can clean this thing all day long, but if it's damaged, then you're just wasting time. You're gonna have to replace it anyways. So if you see on your OTDR, yep, I got a dirty connector at X amount of feet, go out there and look at it first before you sit there and spend all day cleaning it.
So is this clean or dirty?
That's gonna be dirty. Here, let's
Just really dirty.
Can you capture one?
Yep.
Oh yeah.
So look at all the crap on there.
Yeah.
Oh, you're filthy.
A little.
But are you just looking at that little black core or the whole?
The whole thing. So let's see if.
Yeah, because
All right.
the ferrule can actually create scratches, which will create reflections.
So this is going to give you a pass-fail on here too. You hit the button on the side here, and it's going to look at the core. It's going to look at the entire thing and say, okay, there's crap all over this thing. We're failing this. Okay. So again, taking the interpretation out of it. Hope so. So then here's your they call it a one-click. I was like 3, but.
It's better.
Yeah, so they cleaned it right up. So let's captured it.
So what is that off to the side?
Still failed. Still got a little piece of crap here on the side here. So I'm not gonna lie, this jumper cord has been through the ringer. So let's see if it's passed.
That one may be intentionally nicked at one point to show that.
Is it that? Oh.
Do you sometimes need to clean the tester?
Yeah, so anytime that you are going to plug anything into the top of this OTDR, it's literally going to make physical contact with the laser inside here, right? So you always want to inspect this connector before you plug anything in there. It's like $600 or $700 to get the interface cleaned, replaced on the machine itself. So before you plug anything into an OTDR, please look at it. Please run a one-click over this to make sure that you're not introducing crap inside the machine. Because once you start building up junk on the actual laser itself, then you're not getting correct tests down the line. It's the same optics in here that are going to be other places. So again, this connector is actually damaged. It's got a good nick off the bottom of the ferrule here. Now, if you look at the image here, you'll see a tiny circle in the middle. That's your core. Then you actually have what would be the cladding, I guess, around that. It's probably not going to really affect your light coming out of there, but nope, it failed it. Let's see here. Oops. That was one of the dirty connectors on there. Actually, so here's the thing. What this is doing is shooting out a pulse of light. If it sees a splice, it's not always going to see a splice. It's not always going to see a connector. It's just a bunch of math. It's just the speed of light, how long it takes to reflect back on things. It's going to give you a pretty accurate idea of it. It's never going to be 100%. It actually did not see this connector on here. It sees this one up front here, but did not see that one. So first connector I had is at 112 feet, which is 33 meters. So that's doesn't always see everything. This is a very short length here, so it sees this first connector, but then it kind of grouped in this one with that one. So
it's for the sorry for my English. You don't use now launch cable. You use patch cord.
Yep. So
patch cord is a short length because it's less than 3 or 2 meters.
Yeah. Realistically, you should be using like at least 3 meters on there, something like that, to give it a little bit of length. Well, the OTDR itself has 80 meters of fiber wound up in it, so it sees this first connector here. But again, you see one event, and one foot later you have another event that kind of groups the two in together.
So problem with the sun is very short. Need to another length, more length. Huh?
Yeah, you use a little bit longer one if you wanted to on that. It gives you a little more flexibility on that. Yeah. So, but yeah, cleaning connectors is huge. The OTDR is for troubleshooting where your problem is and then how to fix that. And then a power meter and light source is to make sure you're within budget, to make sure your optics can see each other. So.
And when you have a splitter?
When you have what?
When you have a splitter?
Yep.
Yeah.
Okay, so shooting through splitters is something totally different, right? Just quick rundown, a splitter, right, is basically a prism of glass where it just continues to split fibers out. So one fiber comes in, 32 or 64 come out, or 8 or whatever it ends up being. If you're shooting downstream into that splitter, your signal is going to stop at that splitter. You don't get 32 traces off of this thing or whatever. The only way that you're going to be able to do that is you have to have a PON-optimized OTDR and then shoot back upstream through that, okay? So it's going to stop if you're coming to the splitter, but if you start at the customer house and shoot back through the splitter, you can see it that way. So that would be the way that you'd be able to identify any issues on that. So Expo makes it. It's the 730 model that is able to see through splitters. If you do have a PON network, make sure you do get an OTDR that can see back through that, because it's not going to work otherwise. Yep.
On the inspection scopes, you guys have some manual ones, right? That aren't digital?
Yep.
You can just kinda
Yep. So they make microscopes out there and stuff where you're actually like looking into the fiber. The cost in these things have come down so much that it's so much easier to use these ones. But for like $400 or $500, yeah, you could absolutely get a microscope or get something a manual one. What I like is it automatically focuses it and analyzes it and everything. Just again, saving time in the field.
You're not looking at it.
Right. Yep. Exactly. So, guys, got any questions? Did I cover everything that you guys
Want to try it?
Yeah, you guys want to play with this thing here?
So I have a question for you. So your little cleaner, will it clean your optic on the machine itself?
Yeah, it will. So this one-click cleaner here, if you see the plastic top on here, this is what actually adapts to the ferrule of the connector. If you want to go through a bulkhead, which would be on the top of this, you pop this this cleaner off, and you can actually I don't have any fingernails. There we go. This can actually go through the bulkhead, and you can clean the back side of a patch panel as well. So on that note, I did not touch on that. So when you're cleaning a connector, right, you have two connectors that are mated together through a through a patch panel here. If you unplug one and clean this one, plug this back in, and unplug this one, then clean this and plug this back in, they're still both dirty because they make physical contact in there. So when you're going to clean them, unplug them both, clean them both before you plug them back in together. It's going to save you so many nightmares if you have to go back and do that. So yeah, this goes right through the bulkhead, and you can use that to clean that.
You mentioned there was a dB loss for couplers and splices. At what threshold does it fail? You know what I mean? Like if it's 0.5 dB, how many 0.5s? What's the threshold for failure?
Well, you can set whatever thresholds you want on here. So if you want it to be 0.5 or 0.3 or whatever, you can set it to that. So it's 0.5 for each connection. So like for this connection for this event, it would be 0.5 dB threshold.
There's industry standards on it, but
That's
certain
what, yeah,
networks set their own, so they will accept splices at a certain noise level.
What are the industry standards?
It's 0.1 on a 0.1 or 0.3 or something on a splice, and then 0.5 on a connector. It's ITA standards.
And then if you group all those together, at what point do things like, what's the typical fail threshold? Like if you know what I mean? Like
well, so your optics have a range of power that they work in on the far side. So if it has to be between 35 dBm and 45 dBm, you do the math.
And that all comes into when you're creating your loss budget.
Yeah.
Designing your amp.
Yeah, you're going to come out with that because then your fiber itself over X amount of feet you have loss. It's I think it's 0.16 dB per kilometer or something like that. Just the glass itself, you're going to lose power. So you got to look at how much power you're coming out with, how many events you have in between, and what window you have to be on your far side.
How often do you have to replace the cleaner? Like how many clicks do you get out of the thing?
It's supposed to be like 300 or 400 or something. This one, if you look at it, it's just a piece of floss in here that basically comes through the tip, and then it's got a take-up wheel on this side. You can see how much is on there. I think it's like 300 or 400 clicks.
Dry clean, right?
Yeah.
They make with solution, and they also make dry. Dry is usually recommended, especially on the connectors, because what you can actually do is with the wet, if you get them too wet, leave a residue. And then you can actually create friction there as well if you put them in too quick before they dry out. So they usually recommend dry first. And that's actually a selling point when you go to the cleaning supplies. It's we get 600 clicks, we get X amount of clicks. So it really varies on the brand you buy. I haven't really heard that one cleaner is better than another as far as quality.
Questions, comments, concerns? Kind of cover it. Find out where your problem is. That's all we're doing.
The biggest thing is make sure they're clean before you put them in anything.
Yep.
Your equipment.
All right. I hope you enjoyed the OTDR discussion. And now for a little bit with Jonathan at Brinks.
Jirous has grown from 5 gigahertz dishes, 2 gigahertz antennas, into 11 gigahertz dishes that are made for Mimosa and Ubiquity, and they've kind of turned into a global behemoth of antennas that meet a pretty niche spot in the market where you've got great performance, but the price is manageable for a lot of WISPs who are trying to get into things that they couldn't otherwise. One of the intriguing things about Jirous is that back in the early days of WISP in the United States, Europe had already gone through its whole WISP growth. So Prague at one time had more WISP per capita than any other place in the world. And the reason is the government, all of the private companies there drug their feet getting DSL or cable or anything like that. So if you go over there, every rooftop is just blanketed in antennas. So they were solving wireless interference issues long before we even knew what wireless interference was as a WISP market. So a lot of guys coming in with just like standard parabolics, well, they were already making shrouded dishes with foam and all of the stuff that, you know, guys could end up stacking dishes on top of towers and get a lot more bang for their buck, basically. And they were one of the first 5 gigahertz antenna manufacturers that built diplexer into their horn. So you could actually run 2 5 gigahertz links on a horizontal and vertical plane with 53 dB of port-to-port isolation between those two, which back in the day was unheard of.
Yeah.
That was long before dual polarity even existed. So they were doing dual polarity way before MIMO was a thing.
Antenna hipsters is what you're saying.
They were antenna hipsters to the nth degree. And I'm pretty sure they started the whole socks and sandals thing.
Oh.
Yeah.
I mean, I won't hold that against them, I guess.
You probably should. But needless to say, they were solving problems. And that meant for stuff like antennas, they had a product for stuff like enclosures. You know, we're in Oklahoma and the WISP that I run, and you end up screws and seals fall apart and rust away, and they had come up with some really intriguing lock mechanisms and design that was, for the market, didn't exist at the time. And, you know, there was no distributor in the United States, and you ran into this thing where I was calling all my distributors and saying, hey, you guys really need to get this product in here. And nobody would do it, so that's when we sold the farm and decided to bring the first container in. Depends on the market. So in the 11 gigahertz world, the Mimosa B11 is dominating the licensed point-to-point market.
I heard that.
Yeah, dominating it. The Airfiber 11X is a fantastic product, mainly because you can get into that 52 megahertz frequency space. So it does that smaller channel chunk. So it's a little more spectral efficiency in there for what you can get between the 40 and 80 that Mimosa offers. So that's a big deal. But that's kind of, it depends on it's a little relative, because from a CPE perspective, we've got guys that are putting up hundreds of microtik devices paired with Jirous dishes. And that ends up putting you in a place where, so is it how many radios you're putting up, or is it how many links you're putting up? A lot of point to multi-point. We use microtik, Mimosa, and Ubiquity in our WISP, and Jirous antennas with every single one of those things. So I would say, I think the 11 gigahertz stuff is probably winning at this point in terms of links sold worldwide. Ubiquity picked Jirous to design their adapter for their 3-foot and 4-foot dishes. Between the Mimosa 11 gigahertz stuff and the new MIMO, which is going to change the world for everybody, I think.
So they say.
Huh?
So they say.
So they say, right? MIMO changed the world for everybody.
Yeah.
And everybody said it wouldn't because, well, MIMO is really only good if it can bounce off things, you know.
Well, give me the quick and dirty. What is new MIMO?
New MIMO is multi-user MIMO. It's the first bit of technology that allows simultaneous sending and receiving to point-to-multipoint clients. So you end up in a place where if you can combine technologies like beamforming and, say, an 8x8 antenna array, then you can specifically target clients who have better, the clients that are drawing, and simultaneously send from multiple sectors at the same time from the same radio. And that's unheard of. You know, right now everything works in that merry-go-round fashion where you have to wait. And so if you've got a client who's got a really poor signal and it's kind of dragging everything down, regardless if you're using GPS sync or any of the other technologies that help get throughput there, that one client's going to hold up everybody else, whereas MIMO can, you know, especially for streaming, it's going to change the world. I mean, is it Qualcomm who came out with that chip?
I have no idea.
I think it was Qualcomm. But MIMO's a big deal. That's part of the reason Mimosa's doing as well as they are in the point-to-multipoint world.
Again, thank you to Millennium for the great OTDR information, as well as Jonathan from BrinkNetworks.com. He's really keen on that Jirous stuff. You can hear him. Very passionate individual. Sweet dance moves. Ask him about it at the next show you go to. Beyond that, we have a Patreon now. It's patreon.com/TheBrothersWISP. Every little bit helps, even if it's just $1. We appreciate it, guys. Also, hit us on the normal spots, facebook.com/TheBrothersWISP. As you can tell, Mike's been really busy, so there's been less information pumping out. So be sure to pop in there, drop him a note, tell him how much you appreciate him and love him. I'm sure the vendors will be dying to jump in there and tell him how much they appreciate Mike. No, just kidding, just kidding, just kidding. Thank you guys for listening, and we'll see you next time.